Hi everyone, today's class we're going to review the homework number 3 and prepare for the next test on next Monday. So first we're going to go over all the problems in homework number 3 and I will work out all of them on the slides. And then we will point out the key sections in the in chapter 4, 5, and 6 to show you what is the key problems you're going to review and get prepared for the test. Okay, so the first question in homework number 3 is to calculate the interest earned by saving 9,000 for 5 years at 8% simple interest rate. Okay, now so to solve the simple interest problem, the formula you're going to use is this one, I equals to PNI. And question number 2, based on question 1, if P is the principal, I is the effective interest rate per interest period, and N is the number of interest period, what are the correct values of P, I, and N? So to use this formula, of course, you need to decide what is the values for those variables P, N, and I. So because you are the interest earned is by saving 9,000, so that's the principal. So P is 9,000, and I is the interest rate per interest period. And according to this problem, it's compounded annually, so that 8% per year will be the effective interest rate per interest period. So I is 8%, and it's compounded yearly, so the number of years will be the number of compounding periods. So it's N. So the N is 5. So the answer is P is 9,000, I is 8%, N is 5. Based on question 1, what is the interest earned at the end of the 5th year? So this is talking about the interest earned. So it's I equals to P N I. And P is 9,000, N is 5, I percent is 8%. So the answer is 3,600. That's the interest you earned. But talking about the total savings in your account, that's kind of total payback. So the total payback will be the I plus the principal, right? How much you invest and how much you earn under the interest. So the I is 3,600 plus 9,000, which is 12,600. So question number 5 is a new one. It's to calculate the interest earned by saving 9,000 for 5 years at 8%. Sounds the same as the first question, right? But it's compounded annually. So it's a compounding interest problem. So compounding interest problem formula is this one. To use this formula, you first need to decide the values for those variables P and I and N. Okay, so P is still the principal, that is the amount of money you save. So it's 9,000. And I, in this problem, it's because it's compounded annually. So the 8% is still the effective interest rate. Okay, because 8% is the yearly percent and it's compounded annually, so it's the yearly interest rate will be the effective interest rate. And because it's compounded every year, so number of years will be the value of N. So it's N equals to 5. So this is the correct answer. And So now you need to calculate the interest earned. So interest earned based on the formula, it's P times 1 plus I to the power of n minus P. P is 9,000. 1 plus I is 8%. N is 5 minus 9,000 again. So the answer is 4223.95. And based on this interest, what is the total saving in your account? That means what is the total payback? So it's gonna be I plus the principal investment. So it's 4223.95 plus 9,000. And the answer is 13,223.95. Okay, now there is the new question. Calculate the interest earned by saving 9,000 for 5 years at an annual interest rate 8%. Exactly the same as the previous questions, right? But it's compounded quarterly, so every 3 months. Okay, so what formula do you use? Still, this is in a compounding interest problem, so the formula is the same. But the values for those variables are going to be different. So P, of course, is still the principal investment. It's 9,000. But what is the I? I is the effective interest rate per interest period. Okay, but in the problem statement, this annual interest rate of 8%, that's kind of nominal interest rate. It's not interest rate per period. Okay, it's interest rate per year. So you need to convert the 8% per year to some percent per interest period. In this case, it's 3 months. So per 3 months. So what is the interest rate per 3 months? It's gonna be 8% divided by 4, because every year you can compound it 4 times. So it's gonna be 2%. Okay, so I is 2%. And the N is number of interest period. It's not necessarily is the number of years, okay? It depends on how frequently you compound it. If you compound it every quarter, so it's number of quarters during the many years. So during the 5 years, how many quarters do you have? So it's, you have 5 years, right? And how many quarters do you have per year? 4 quarters. So in 5 years, you have 20 quarters, which means the N is 20. Okay, so this is your correct answer. So based on these values and the formula, what is your interest earned? Still use this formula. P is 9,000. 1 plus I is 2%. N is 20 minus 9,000. So the answer is 4373.53. And based on this, what is the total saving in your account at the end of the 5th year? So that's total payback. It's I plus P. So it's I plus 9,000, which is 13,373.53. All right, question number 13 is about the equivalent values. Okay, so Tom wants to invest his money in the market. He is interested in one stock which could yield an interest rate of 5% annually. So if Tom invests 10,000 at present, so 10,000 is a present value for 6 years, how much in total he can get back at the end of the 6th year? Okay. So to solve this problem, you first need to draw the cash flow diagram. But so from these 4 options, which one is the correct from Tom's perspective? Okay. So Tom's perspective is different from the stock market, right? Or from the company whose stock is bought by Tom. So because Tom needs to pay 10,000 at present, so that payment is outgoing cash flow. So it's an arrow going downward, 10,000, and no cash flow during every year. But at the end of the 6th year, Tom needs to get back the total. Okay, so that's gonna be his receiving, and it's unknown, and it's a future value. So, and the I is 5%. So based on this, what is the correct answer? So it's gonna be this one. And based on the question, what formula do you use to calculate how much total Tom can get back? Because the total Tom can get back is actually the total payback. Okay, it's not just the interest, it's interest plus the principal. Okay, so if interest is P times 1 plus I to the power of n minus P, so P plus I is gonna be this plus I, right? So it's P 1 plus I to the power of n minus P plus P. So these two are cancelled. So the final answer is P times 1 plus I to the power of n. So this is the formula you can use. And based on this question, how much in total Tom can get back? So use that formula. Your future value is, it's not 9,000, it's 10,000 times 1 plus 5% to the power of n. So the answer is 13400.96. Based on question 13, if you use the factor method to solve this problem, what is the correct factor to use? So the factor method to use factor method, you need to determine what equivalent value you're looking for. So now you're looking at the future time. You want to know the future value of the present investment of 10,000 by Tom, right? So you're looking for future value given the present value. So it's F/P I% and N. That's the factor. And I is 5%, N is 6. Okay, so it's this one. And so you're going to check the table in Appendix C, the table of I equals to 5% to look for the factor. And that factor is gonna be this one. Question 18 is another problem. So suppose the contribute $10 per week. So $10 per week is equal to $520 per year. So you're contributing this much money into an interest-bearing account that earns 6% a year. Okay, this 6% is compounded per year. Okay, which means if you're using 6%, you're going to use the $520 per year as your annual investment instead of $10 per week. Okay, that's probably one less pizza per week, which means if you skip one pizza per week, that money saved can be almost $10. Okay, and if you save that money into a saving account at 6% interest rate per year, you can save a lot of money. So now, if you want to save this, keep doing this every year for 15 years, how much you can save. Okay, so based on this problem, what statement describes the question correctly? So this is to look for the future value of your current, the continuing $520 saving per year for 15 years. Okay, so it's to find the equivalent future value of an annuity. Okay, future value of an annuity. And based on this problem, if you use factor method to solve the problem, which formula is correct? So factor method, the formula, you're looking for future value, okay? And given annuities, so this is the formula. And the annuities, because the interest rate 6% is per year, so you cannot use $10 per week as your annuity. You need to use the $520 per year saving as your annuity. So A is 520 and I is 6%, N is 15 years. Okay. And so how much money would you have saved at the end of the 15 years? So you need to calculate the F now. F equals to A times F slash A. I equals to 6%. N is 15. A is 520. And this factor is 23.2760. So the answer is 12103.52. Okay, the last problem. Assume that you are given a cash flow diagram as in below to calculate the equivalent present value of all the cash flows on the timeline. So it's a multiple cash flow problems. The first step is to determine how many different cash flows you need to convert to the present time as parts of 0p. Remember what we have done in the class. We always look at how many parts you need to convert for P0, okay, for present worth. So in this cash flow diagram, you have 3 different cash flows. So you need to have 3 parts for calculating the P0. So 1 part, 2, part 3. Okay, so for the first question, how many parts do you have for P0? 3. And what is the value of P0? So P0 is from 3 parts. P0-1 is from the $200, it's negative. and it's a value at the end of the first period. So it's compared to the present value, it's to convert the future value to present, right? And the P0-2 is from the 400 at the end of the second year. It's still a future value converted to present value. And the last part is P03 is from the 100 at the end of the sixth year. It's still to convert the future value to present value. Okay, and well, in these four answers, among these four answers, they're all positive, but actually it's an outgoing cash flow, so there should be a negative sign in front of it. But since they're all, since they're all the cash flows are negative, so we don't have to differentiate the negative from the positive. So it's fine to just ignore the signal for this problem. But of course, you can include the negative signal. Okay. And in the final example or in the test, I am going to include the signal all the time, so you don't get confused. Okay. So now let's continue to calculate what is P01, P02, and P03. P01 equals to, if you want, you can include the negative sign. Okay. It's 200 times, it's to convert a future value to the present value, so it's to find P/5/F. Interest rate is 20%. Because it's only 1 year from the present time, so it's converted one time, so it's n equals to 1, and this is 166.66. And the P02 is from the 400 P/F still 20%, but it's 2 years from the present time, so it's compounded 2 times, so n is 2. The answer is negative 277.76. P03 is from the 100 at the end of the 6th year, P/F 20%, and it is 6. Okay, n is 6, so this is 33.49. Okay, so the P0 is the sum of these 3 parts. The total is 477.91. Okay, so it's gonna be this one. All right, the last problem is about the effective interest rate. So a credit card company charges a nominal interest rate of 12% compounded monthly. So nominal annual interest rate compounded monthly. So what is the effective annual interest rate? We have a formula, right? So this is the formula you need to use. But to use this formula, you need to determine what is R, what is M. Okay, so R is the nominal annual interest rate, which is 12%. M is the number of compounding period per year. So because it's compounded monthly, is compounded every month. So for a year, it's compounded how many times? Because there are 12 months a year, so it's compounded 12 times. So M is 12. So this question, R is 12%, M is 12. Okay, so this is all for the homework number 3. And now let's just get prepared for the test number 2. Okay, so in the test number 2 is going to cover chapter 4, 5, and 6. So if you remember, chapter 4 is we start to talk about the interest. And because of the interest, we cannot compare amount of money, or we cannot compare values, economic values at different time spot. We need to always convert everything to the same time spot, either the present time or the future time or the every year. Then we can compare. Okay, so interest, there are 2 types of interests. One is called simple interest and the other is called compound interest. So you need to understand what's the difference between them, and then what is the formula to use for each of them. Okay, simple interest, we have this formula, and because pay attention to this. The I is just the interest. If you want to know the total payback, you need to plus the interest with the principal. And so this is an example. I think you want to just practice on this. Try to use the formula, okay? And try to understand what's the difference between interest earned and total payback. And then there is the formula for compound interest, okay? Still, this formula is for I. If you want to calculate the total payback, you need to add the principal and work on this example, okay? And another problem is, what if the interest is not compounded every year, it's compounded every month, or compounded every month? Oh no, if it's compounded every month or compounded every quarter, so the compounding period is gonna be different from a year. So what if that happens? This is an example to tell you, okay, how do you determine what is the interest rate you want to use in the calculation? And cash flow diagrams. So the important thing is you need to determine the perspective, which viewpoint do you use, okay? And then if you use different perspective, the direction of these arrows are gonna be totally different. And then we learned how to convert the values to its present value or future value or annuities, right? And we know there are factor methods we can use. So this is to find the future value given P. And for this problem, we use 2 methods. One is for this problem, what we used is still the formula method, okay? But here we introduced the factor method, and we introduced this table where you can find the value of the factor. And then we talk about to find the P, one given future value, okay? So still here we're using the formula method, but then we introduce the factor method, and we can see that the final results are the same. Okay, so then we can also find the future value given the present value using either the formula method or the factor method. Then we try to convert annuities to future value, present value, or we convert the future value to annuities, or convert the present value to annuities. So it's the conversion between the F and A, P and A, okay? Different directions. And then we introduce the factor method as well, because the formula methods are very complicated here. And then we showed this example to teach you how do you find out f given a, okay, and how do you find out p given a. And this table is also very important. You want to make sure you know how to write these factors correctly, depending on the question, okay? And then this is the multiple cash flow problem. So you have multiple cash flows and you want to convert all of them to the present time or future time or annual and every year. So the first thing is you need to decide how many parts you have in this present value, and then you calculate each part, and then you sum all of them as your total present worth or future worth. Okay, so this is the steps you can follow to calculate the multiple cash flow problem. And then we introduce the nominal annual interest rate. You need to differentiate the nominal annual interest rate and the effective annual interest rate and the interest rate per interest period. These are the three concepts differently. Okay, so these practices can help you to differentiate these three different concepts. And then we introduced the formula to calculate the effective interest rate. So to use that, you need to determine what is R, what is M, and you want to practice on this problem, okay? And this is another example about converting multiple cash flows to a present worth. Okay, try to see if you can follow the steps and you can get the same answer. Then we talked about the bond value. Okay, the bond value is the price you are willing to pay to buy a bond. Okay, and we have a formula Vn equals to this long formula to use to calculate the price you are willing to pay. But to use it correctly, you need to determine what is the value for C, for N, for I%, and for R, and for Z. Okay, and please work on this example to see if you can get those variables correct. And try to work on this example as well. I think we have shown. Okay, we have seen this before. It's to use the present worth method. This is just a future worth method. Okay, so you can use present worth, future worth, or annual worth. It will give you the same answer if you want to accept a project or no. But in the test and the final exam, we will let you know if we want you to use the present worth or future worth method. And in chapter 6, we have discussed the multiple alternatives, right? We want to know how do we compare different alternatives. So we said we are going to see two types of alternatives. One is called investment alternatives, which means invest some amount of money at the beginning, and then every year you are going to have some positive cash flows, negative cash flows. Okay, and you want to decide which investment is worthy. So basically you will have two positive present worth, and you want to compare which present worth is bigger, and that is the better option. Another type of decisions you're going to make is called cost alternatives, which means all the cash flows are negative numbers, which means you only spend money at the beginning, and every year you're going to spend a little money as maintenance or as repairing fees, and you never have any positive cash flow, except that maybe at the end of the project life you can have some salvage value, so you can sell your project to someone else and you get some positive cash flow at the end of the timeline. Okay, but still you're going to have a lot of negative cash flows um, um, every year and at the beginning. So this is type of cost alternatives, and the results of this type of problem is all negative. So if you want to compare two negative present worth, you're going to choose the less negative one as the better solution. Okay, because the less negative one means you are going to pay less. So try to work on this example and try to understand why do we choose the less negative one as a better choice. Okay, so these are all the key points you need to focus on while you're reviewing all the contents, right? If you are not going to cover everything, at least these problems you need to work out again. Okay, so don't forget about the test on next Monday, and wish you good luck.